Hello students, let's start the third part of the second chapter, Pythagoras Theorem. In this part, we have to study the Apollonius Theorem. I have written the shortcuts here. This is 80, means Apollonius Theorem. When it will come if there is a midpoint or a median. What is median? The segment which is joined to the midpoint is called a median. And remember this, आपको ये याद रखना है, अगर किसी भी ट्रायंगल में आपको मीडियन या मिडपॉइंट दिखा तो इसका मतलब आपको अपोलोनियस थ्योरम यूज करना है. So remember this point, you have to use the Apollonius theorem if the midpoint and the median is given. What it tells? It tells us that these are the two sides which are related to the median. So which are they? AB and AC. So it tells us that AB square plus AC square. The square of these two sides addition equals to 2AD square means median square plus the half part of this one is 2BD square. This is called Apollonius theorem. So again I am going to tell you the application of this one. In this one D is the midpoint, AD is the median. Then we are going to use the Apollonius theorem. But its application is there. See, this is the parallelogram. This is A, B, C, D. And we know that the diagonals of parallelogram are bisecting each other. So observe this one. Observe this figure ABD. So in triangle ABD, if you split the figure, you will get it like this. This is B, this is A, this is D, and this is the point O. So what do you observe? In parallelogram, the diagonals bisect each other. It means BO equal to OD and AO equals to OC. Triangle ABD, segment AO is the median. And therefore, in this one, you can use the Apollonius theorem. Again, the sides which are related to the median are AB square plus AD square equal to 2AO square plus 2BO square. Instead of BO, you can write it OD also. And this is an application of Apollonius theorem. Remember, Apollonius theorem will come if the midpoint or the median is given either in parallelogram. Let's see the sum which are related to Apollonius theorem. See in this diagram, D is the median, AD is the median and D is the midpoint. So therefore, I am going to use Apollonius theorem. So you have to write it like this. In triangle ABC, segment AD is the median. Either you can write it D is the midpoint. This is given. So by Apollonius theorem, it tells us that the two sides which are related to AD are AB square plus AC square equal to 2AD square plus 2BD square. Now substitute the value. AB's value is given 11, AC's value is given 17, 2 AD value is given 13, 2 BD square will be as it is because its value is not given. 11 square is 121, 17 square is 289, 2 into 13 square is 169 plus 2 BD square. Okay, so if we add these two, you will get it 129, 9 plus 1, 0, then it's 11, 410 and then it will be 328, 169, 2 8 9 the 18, 12, 13, it is 338 plus 2BD square. Now it will come on this side 410 minus 338 equal to 2BD square. So it will be, if you subtract it, you will get it 72 equal to 2BD square. 2 will come on this side, 72 divided by 2 equal to BD square. So BD square equal to 36. If you take the square root, you will get it BD equal to 6 centimeter. If it is given centimeter, then you have to write it centimeter. Otherwise, you have to write the units. But here we have to find out the BC. So BC is double to the BD. Either we can say that BD is half to BC, because both the parts are equal. Therefore, the smaller part is half to the larger. So BD is given 6 equal to half into BC. 2 will come on this side. So you get the value of BC equal to 6 into 2. So BC equals to 12 centimeter. Therefore, the length of BC is 12 centimeter. Let's start the sums which are related to the Apollonius theorem. So, in this one, prove that the sums of the squares of diagonals of a parallelogram is equal to the sum of the squares of its side. It means in this sum, parallelogram is given. This is A, B, C, D. These are the diagonals, and which are intersecting at the point T. So first, I told you that if the parallelogram comes, then you have to write it. Quadrilateral A, B, C, D is a parallelogram. Then diagonals of parallelogram bisect each other. Therefore, we can write it AT is half to AC and BT is half to BD. Always remember, if any sums which is related to the parallelogram comes, then you have to write these statements as it is. Draw the diagram. ABCD is a parallelogram. Diagonals of parallelogram bisect each other. Therefore, AT is half to AC and BT is half to BD. Give the number 1, give the number 2 to this one. Okay. So, what you have to prove that this square of all sides of this one. But here the parallelogram is given. So, we have to use Apollonius theorem here. So, I am going to take triangle BAD. So, in triangle BAD, segment AT is a median, and therefore by Apollonius theorem, which is a median AT. So these are the two sides which are related to the AT. Is one is AB square plus AD square equals to 2AT square plus 2BT square. Give the number 3. Now substitute the values of AT and BT. So from 1, 2 and 3 you will get it AB square plus AD square plus 2 will be as it is. AT's value is half AC. So half into the AC whole square plus 2. Again the BT's value is half BD the whole square. So 2 will be as it is. 1 square is 1. 2 square is 4 into AC square plus 2 into 1 square is 1. 2 square is 4 into BD square. 2 1s are 2 2s are 2 1s are 2 2s are. So you will get it half AC square plus half BD square. So AB square plus AD square equal to half AC square plus half BD square. So from this one, if you multiply by 2 to both the sides, multiplying by 2 to both sides, we'll get it 2ab square plus 2ad square equal to, if you multiply by 2, 2 will be cancelled, ac square, and here the bd square. So can I split this 2 as an ab square plus ab square and ad square plus ad square. So we'll get it ac square plus bd square. So we know that in parallelogram AB is equal to CD. So AB square plus CD square, AD square plus AD is equal to BC square. So equal to AC square plus BD square. So you will get it rearranging AB square plus BC square plus CD square plus AD square equal to AC square plus BD square. Now see, prove that the sum of the squares of the diagonals, it means AC square plus BD square, of a parallelogram is equal to the sum of the squares of its sides. Squares of its sides. AB square plus BC square plus CD square plus AD square. This is the sum of all the side square equal to the sum of the square of the diagonal, is proved by Apollonius theorem.